All right, P.
Create a flash on YouTube? Like your own channel?
Yeah, I have my own channel.
You have your own channel?
Mm-hmm.
So they should all subscribe. Yeah.
All right, now let's listen. It says base angles P and R. So if I say P, A, oh, I think I did it wrong.
Yeah, that's what. Oh my gosh, it's like they're not just
That's still not right.
No, because it would have to be like P.
I had TR, but TR didn't work. It needed to be AR. What did I do?
Yeah.
Wait a minute, it's right.
Yeah, we should do a quiz.
Oh, I did that wrong. It should have been PT. Okay, make this correction. I will correct the worksheet before I send it out to you. All right, it should have been angle T and angle P. R.
Redo the worksheet. Just one problem.
Yeah. These are our base angles. What do we know about base angles?
Yeah.
So the way it was written, it didn't make any sense. So 10x plus 17 is equal to 14x minus 7. That was the intent. So if I subtract 10x and I add 7, I'm going to get 24 is equal to 4x. Or x is equal to what? Right. Now, I did not ask for x. I asked for measure of angle A up there. Well, we're going to find P first. So what's the measure of angle P? P happened to be 10x plus 17. So it's going to be 10 times 6 plus 17 gives me 60 plus 17. And that's indeed 77, correct? All right, so now you tell me how we're going to get A. These are parallel sides. If I were to trace this, this would be what letter? A C. Therefore, they are same side interior supplementary. So measure of angle A is going to be 180 minus 77. I believe it's 103. Okay, next question. Caitlin. Okay, problem 4 is an is an obtuse triangle. So this is, yeah, in a minute. This is 4. All right. So what I did is, in order to, I extended this side, I dropped this down, and this is perpendicular. Then the numbers on this picture are 15, 12, 10, and 7. Now, looking at this, what numbers are on the sides of your triangle? 12, 10, 15. Is 7 a side? What is 7? How do you know? Yeah. I've got you trained well. I can't tell you how important that is. When I tutor kids, they have no clue. It's like, oh my gosh, you don't know what to do then. All right, so how do we find perimeter? So that's 10. Why am I leaving 7 out? Not a side. All right, so that's 22 plus 15, and I do believe that's going to be 37. What's the area formula for a triangle? Okay, so if you have a highlighter, highlight this because you have to know this tomorrow, and if you don't know this, it is going to be so sad. Now the question is, who's the base and who's the height? Yes. Okay, so you're going to have to look. There's the perpendicular. This line will take you to the base, and the base is 12. So half of 12 is 6 times 7 is 42. Is that what I said? Okay. 5. So I'm going to squeeze 5 here so that you can still see. Oh, darn. this picture. What else do you have to know for tomorrow besides 45, 45, 90, and 30, 60, 90? What kind of triangle is this one? How do you know it's 45, 45, 90? That means these angles have to be congruent. What's the sum of the angles of a triangle? And how much is taken up? 90. So if 90 is taken up, those sum to 90. What is each one of those? Okay, so now what do we do? This is x, this is, and this is, all right, and this is your equation. You're going to say 6 equals x square root of 2. You're going to divide by square root of 2. So you're going to say x is equal to 6 square over square root of 2. And what do we do? Multiply by square root of 2 over square root of 2, which is 6 square root of 2 over, all right, what is this? Square root of 4, which is 2. And does that reduce? So that's going to be 3 square root of 2. In other words, that's 3 square root of 2, and this is 3 square root of 2. Do you have all your sides for a perimeter? All right, how do you do perimeter? So we're going to say 3 square root of 2 plus 3 square root of 2 plus 6. Okay, if these radicals are creating issues, you can let's say r for radical be square root of 2. So how would you add 3r plus 3r plus 6? How would you add that? 6r plus 6, and you'd stop, wouldn't you? Well, what is r? So that's 6 square root of 2 plus 6.
What about the area?
Yeah, I'm not done. Any questions on perimeter? Okay, so now let's go to area. So our area is going to be, oh, what's the formula? Now, what's the relationship between any base and height? So you're going to look at the perpendicular, what sides form it? 3 square root of 2 and 3 square root of 2. All right. Okay. What you want to do is you want to add this side plus this side plus this side. Do you see how I did that?
But then what's 3r?
All right. Some people have problems adding these. And what I was saying is the square root of 2 is like a variable. So if we replace square root of 2 with a variable, you all would not even hesitate to tell me that's 6r plus 6. You with me?
Yeah.
But what is r? No, what is r? Square root of 2. So I just replaced r with square root of 2. Did you have to use r? No. But you need to know that you can add the 3 and this 3 to get 6 square root of 2, but you can't add that 6 and that 6 square root of 2 because one's a radical and one's not. Okay, so when we go to multiply these, what is 3 times 3? 9. What's square root of 2 times square root of 2? Square root of 4 all over 2. What's square root of 4? 2. And what happens to the 2's? So this is, oh, did I really? Guess what? Oh my, I had the wrong formula. Yeah, borrow your pencil. I did a parallelogram formula. Don't do what I did on your test tomorrow. Thank you. All right. Next. Question? That's it.
The area's wrong. I got all
No, that right. 9 is correct. What I read was wrong. Next. Number 9A and B. Okay. So the dimensions of the tablecloth Amy is making, and I should have said, sorry, I could have made this better. I will try to remember to make this better before I post it on Remind 101. I should have said the dimensions of the rectangular. Would that have helped?
Will you say in A that it's a rectangle?
Okay.
Yeah.
I saved myself.
I was thinking that you were writing the question and I was like,
Okay, so we have this rectangular tablecloth. It's 108 long. It's 72 wide. Now, if she's putting fringe on it, where does that fringe go? It's going to go all the way around there, correct? Do you know what the common mistake here is?
Area.
Well, true. That's one of them. This is the other one. This is what they do. What's wrong with that? There's two sides. How many sides are there to a rectangle? 4. So we need two 108s and we need two 72s. Now, I said, right or wrong, I said that was 360. Is that correct? Okay. Now what does she, now she has to, but before she puts the fringe on, she has to buy the fabric. So now what are we looking at? Area. Now, theoretically, she would have first of all taken that to feet. Okay, but I didn't go there. So now we do the area. What's the area formula for a rectangle? Base times height, and that's where I got 7,776. Now that's going to be square inches because it's a rectangle. This is just going to be inches. Next, yeah. And that was everybody in 6th period too, so I think it's whole year.
Wait, yeah, it is full year.
I probably haven't. Yeah, I don't think I've gone in Portal. Pardon?
I was asked 5 times.
Oh, the whole year?
Yeah.
Maybe not the semester. They might have, but they might have been doing it for the whole year, not just the semester.
Yeah, it's whole year.
Well, they'll fix it when they go to do exam exemptions. All right, next. 6th period had the same issue. Okay, Caitlin. 14. Graph the parallelogram with the vertices. You have 2 of these. 3 of these? Maybe there's only 2. And I put 3 to make sure you were covered. So what did they tell you it was? To start. What do we already know about this figure? It is a, bless you, parallelogram. We're going to plot -2, 2. That is Q. We're going to do 0, -2. This is R. We're going to do 2, 4, 6, 1. This is S. And then we're going to go over 1, 2, 3, 4. And then we're going to go up 2, 4, 5. And that is T. So the question is, what special figure do you think this is? I think it looks like a rectangle. What's the simplest way to show it is? Distance formula for the what? Diagonals. Because what do you know about the diagonals of a rectangle and no other figure? They're congruent. So that means that by drawing in those diagonals, do you see which ordered pairs you have to work with? Right, so we're going to work with TR first. So that's going to be the square root of something. So T is 5. Let's see, no, let's do 4 minus 0 squared. Those are the x's. And then I'm going to take the y's, which is 5 minus a minus 2, which is 5 plus 2. So this is going to be 4 squared plus 7 squared. Notice how I'm leaving them in parentheses. That was one of the issues on the projects. 16 plus 49. No, but people, when the number was negative, they dropped the parentheses, and that ended up to be -16 instead of +16. And this is going to be 4, 5. I believe that's the square root of 65.
Any square rooted negative number is always positive, right? Because it's just multiplying negative by negative.
If it's inside the parentheses, yes. If you were to do -4 squared, that's -16. If you do -4 squared, that's +16. Right. Only 4 is being squared, not the negative. The parentheses tell you both is. The old calculators, and I don't know about the Casios that we have for the EOC, used to do that incorrectly. And that issue came up when we got into the graphers. All right, so we got QS now. So we got to find the distance of that diagonal. So you have to study this. You have to know that the diagonals of a rectangle are congruent. So QS, we're going to do 6 minus a minus 2, which is 6 plus 2 squared. And then we're going to do 1 minus 2 squared. So this is going to be 6 plus 2 is 8 squared plus negative 1. Notice my use of parentheses. This is going to be 64 plus 1, not minus 1, which is square root of 65. What did we just show? So you're going to say rectangle, and you're going to tell me why. Because diagonals are congruent.
What does that even stand for? VLC?
That's because. Yeah. I learned that from you all. All right, that was 14. Next question. Karen. 10. All right, I'm glad you asked this.
If I got my project back to me and then I just fix something real quick on it, like to break something, and then handed it back to you just like right now, would that be much late?
In other words, you're telling me you want your project now to fix something.
Yeah, just like today.
Well, I'm not going to get up to go get it, but you can do it in the period. Yes, Caitlin. Rectangle, let's see. QRTS, QR, what is this? QRST. QRST is a rectangle because diagonals are congruent. Does that look better? All right, number 10. They told you the area of a triangle is 145. They told you the base is 15. I can't imagine the EOC not going here. Okay? It's a triangle. What do you know about the area formula for a triangle? Area equals 1/2 base times height. Where do you think you're going to substitute 145? Why? Because it is what? Area. Where do you think you're going to put 15? In for base. And what do you think you're going to do? Solve for h. So you've got 145 is equal to 7.5. Where did I get 7.5? Okay, so now what do you do? Divide by 7.5. Someone with a calculator do that. I'll check my answer. Is that what I got? Okay, yeah, 3 repeating. So the height is 19.3 repeating. So the key is to identify your formula, write the formula, and then you can go from there and say, oh, well, that plugs there, I can solve for h. You do have one of these on your test. That's why I put 2 on the worksheet. Next. Number 15. Graph the parallelogram. Again, what did they tell you about this figure before we... It's a parallelogram, and that's really significant that they tell us it's significant that they tell us this. All right, so if you plot these ordered pairs incorrectly, is that going to affect your problem? All right, we want to do 15. We want to do -4, -1, and that happens to be j. Then we want 1, -1, and that happens to be k. Then we want 4, 3, I think that's L. And then we want -1, 3. And this is M. So let's connect these. And that's one of the reasons why you want to graph these, because you want to see what it looks like, and then you can verify.
It looks like a rhombus.
Okay, so what's the easiest way to show it is a rhombus? What's special about a rhombus that's not as special about a parallelogram? Okay, so we could do 4 distances. What else could we do? The diagonals are perpendicular. Now, if I want to show that these diagonals are perpendicular, what do I need to do? Slope. How many slopes? Do you want to do 2 slopes or 4 distances? Okay, do you agree that that's the least amount of work? Okay, so this is number 15. So J happened to be -4. -1. L was 4, 3. K is 1, -1. That's a 1. And the other one is -1, 3. All right, so please show me what you're doing. I'm going to do the slope of MK. That way I can follow what you've done. So I'm going to say -1 minus 3 over 1 minus a -1. So that's going to be -4 over 2, which is what? -2. That's one of them. So now we're going to say the slope of JL. So I'm going to do 3 minus a -1. And then I'm going to do 4 minus a -4. So that's going to be 4/8, which reduces to what? 1/2. You have -2. You've got +1/2. What's that relationship? Opposite reciprocals. So JKLM is a rhombus, and what's the reason? Because the diagonals are perpendicular. Now, would it be wrong to say perpendicular bisector? No, because they told us it was a parallelogram and the bisect is part of the parallelogram. But perpendicular will suffice. Other questions? Yes, Caitlin? 13. Quadrilateral is a trapezoid. On 13, I did not say that it was any special trapezoid. You with me? I did not say that it was isosceles. So if I don't say it's isosceles, you cannot assume it is isosceles. All right, so they told you that this is 55 and this is y. You all flew through this assignment. Now I've asked for x and y. How do I get that? So x is going to equal 180. Why did you do that, Jeff? Why are they supplementary? Because they're same side, and if it's a trapezoid, we have one pair of parallel sides. So that's going to be 58. Is that right? How do I find y? 180 minus 55. So I think that's 125. Is that what I did? Okay. Other questions? And now it's the same reason, because these are... We've still got a couple minutes. Exactly. Now, if you graph it, you should be able to see possibly which two sides might be congruent and save yourself from doing a third distance. Right? If it definitely does not look like all three, then you need to do the two that appear to be congruent to show isosceles. All right, any other questions, or do I stop the video?
You're not going to do it?
No,
Why?
because you know how to do it.